Welcome back to the Azure AI Foundry series. In the last video, we covered what Foundry is and why it matters. Now, let's dive deeper into how it actually works. In this episode, we'll explore the core architecture, resource hierarchy, security model, and governance features that make Foundry enterprise ready. Let's get into it. At the heart of Foundry is a three-tier resource model. At the top is the AI Foundry Hub. This is your shared management boundary where governance, security, and infrastructure are centrally controlled. Think of it as the organization's AI backbone. Below the hub live projects, isolated workspaces scoped to specific teams, use cases, or application. Each project gets its own folder-like structure for agents, models, and data, keeping work organized and secure. At the bottom are your resources, models from the catalog, datasets, connections, compute, and deployment endpoints. These live within projects and respect project level boundaries. The key benefit: you set security once at the high level, and all child projects inherit those controls. Developers don't need to manage complex infrastructure. They just create projects and build. How does it look like an AI Foundry? So let's just create a new one in the portal, Azure AI Foundry. And the only thing you need to define is a name. So let's call it AI Foundry PRD from production. Let's select a region, and then you have to type a project. So every Foundry, when you create it, it comes by default with one project, and that's here where you define that name. We are going to call it use PRD project and create. Once a Foundry is created, you just go to the resource overview and go to the portal. And this is how it looks like. On the left side, you are inside the menu of a specific project inside the Foundry. But if you want to see the Foundry and all the projects, you go to the Management Center. Here you see on the left side the name of the hub or the AI Foundry resource. And on the right side, you can see the projects. You can create as many projects as you want inside a hub. You can then see users for RBAC assignment, connected resources. These are at the hub level, and they will be inherited by all the projects inside the hub. However, at the project level, you can also specify different users RBAC assignments. The same for resources. So by default, they inherit, but you can also make them granular. Let's look at how Foundry is architected from bottom to top. Layer 1, infrastructure. Azure Compute, GPU, CPUs, managed store and networking. All fully managed. Layer 2, Azure Services, integrations with OpenAI, AI Search, document intelligence, storage, keyboard. This connects securely via the hub. On layer 3, we have platform services, the Foundry API, SDK, and orchestration engine that brings everything together. This is where agents, evaluations, and prompt flow runs. On layer 4, we have your solutions: chatbots, agents, copilots, and custom apps built on Foundry. This layer approach means developer focus on layer 4 while IT manage layers 1, 2, and 3 at the hub level. Clean separation of concerns. Foundry security is built on Microsoft Entra. Every user is authenticated via Entra ID, and every action is governed by Azure role-based access control. Here is how it works. When you assign a user to your Azure subscription or Foundry resource, you grant them a role. Foundry has built-in roles like AI project owner, full control over a project, create agents, deploy models, manage team, or an AI project contributor can build an experiment but can't manage permission. There are also roles like project leader, cognitive services OpenAI contributor, and so on. You can also create custom roles for fine-grained control. At the whole level, roles like cognitive services contributor or user access administrator control infrastructure and permissions. At the project level, roles control who can build, deploy, and manage AI assets. This means if someone leaves your organization, removing them from Entra ID automatically revokes their access to all Foundry resources. No manual work is needed. So there are two ways to assign a role-based access control. So the first way is in the Foundry itself through the access control tab, and then you can add role assignment, and you just find the group that you need or the role. For example, you see here there is a account owner, AI administrator, AI developer, AI project manager, user, and you can actually read what they have access to here. If you need to see the details of one specific, you can click on view and you will see all the permissions for that role. Or in the Foundry itself, at the hub level, you can use add a user. It actually looks easier. And then you have only three roles: account owner, project manager, or user. And that's basically it. When deploying models in Azure AI Foundry, you have two major decisions to make: your deployment pattern and your data processing location. First, choose between standard and provision. Standard deployments use pay-per-call billing, perfect when your usage varies. Provision deployments give you reserve capacity measured in provision throughput units, ideal when you have high predictable volume and need consistency, low latency. Second, decide where your data gets processed. Global deployments dynamically route to any Azure data center for the best availability and highest throughput. Data zone deployments keeps processing within a Microsoft specified zone, like keeping European data in the EU. And regional deployments process everything in your chosen Azure geography. This gives you combinations like global standard, your starting point for most workloads, or the regional provision for dedicated capacity in a specific region. There is also global batch 4. Large-scale async processing at 50% discount within a 24-hour turnaround time. Here's what matters. All these deployments type perform the exact same inference operations. The differences are in billing, scale, performance, and where your data gets processed. You choose based on your volume, compliance requirements, and latency needs, not on model capabilities. Let me show you how that looks like in the portal. So again, we are in the portal in a specific project. We just go to my assets, models and endpoints, and we deploy a model, a base model. I'm going to select a 4.1, for example. And here is where you select the deployment types. So all those options that we saw on the slide, they are here. So here is where you decide based on your compliance requirement, region requirement, etc. And that's basically it. The inference is exactly the same. For enterprises requiring strict network controls, Foundry offers managed networking. This is huge for regulated industries like healthcare, finance, and government. When you create a hub, you can choose Internet outbound allowed by default. Resources can reach public internet, great for quick setups. Approve outbound only. Only specified Azure services and endpoints are reachable. Everything else is blocked. You must explicitly allow outbound traffic via rules. This is typical for enterprise. Or disable. No outbound access. Completely locked down. Foundry also supports private endpoints, which means your hub's data never touch the public internet. All traffic stays within Azure's backbone or your private network. For compliance, Foundry hubs can enforce customer managed keys for encryption, manage identities so no credentials are stored, audit login via Azure Monitor and application insights, compliance certifications, SOC 2, Type 2, HIPAA, and PCI DSS are built into Azure and Foundry inherits this. This architecture makes it easy to meet regulatory requirements without extra effort. Foundry fits naturally into enterprise CE/CD pipelines. Here is the typical workflow: develop, build agents and evaluations into a dev project or chatbot, test, run automated evaluations to validate quality. 3. Deploy push to staging via API or SDKs. 4. Validate. Run the final checks, A/B testing with real users. 5. Promote to production. Deploy via API or DevOps pipelines. 6. Monitor. Track performance in Azure Monitor and App Insights. And then iterate. Use metrics to improve and repeat. The Foundry API and SDK, you have the options in Python, C#, JavaScript, and Java. Make automation seamless. You can version your code in Git, run evaluations as part of your pipeline, and deploy via Azure DevOps or GitHub Actions, just like code. The Foundry REST API gives you programmatic access to models, agents, evaluations, and deployments. This means your DevOps engineers can manage Foundry resources the same way they manage infrastructure. Once you are in the model deployment, you click one of those, and I just want you to show you how easy it is to get started. Whether you are a Python developer, JavaScript developer, you want to use the REST API from another programming language, you have Java and you have C Sharp. And you can use authentication via Entra ID or key. You have all the examples here, so it's super easy to get started. So what are you waiting for? An organization set up three Azure AI Foundry resources to separate environments: development, production, and sandbox. Each resource acts as a security and governance boundary. Within the production resource, we have four projects. For example, the Azure Assistant, which handles sensitive employee data, is configured with strict isolation, private endpoints, and network restrictions. Only Azure administrators have access to this project through role-based access control. The Customer Copilot is customer-facing and is to scale. It uses global standard deployment for high throughput and dynamic routing across Azure's global infrastructure. The internal BA project processes financial reports, highly compliance critical, is configured with customer managed encryption keys, dedicated audit logging, and meets SOC 2 and HIPAA requirements. And the innovation lab is where teams test new capabilities. It's configured for rapid iteration with lower cost deployment options, but still inherits the production resource security policies. What ties this together? Microsoft Entra ID authenticates all users. Role-based access controls exactly who sees what, and all network traffic stays on Azure's private backbone. Compliance teams can audit everything, but developers maintain agility within their project boundaries. This architecture balances two critical needs: centralized governance at the resource level and team independence at the project level. You get enterprise security without sacrificing developer velocity. Here is what you should take away from this video. Foundry three-tier model hubs projects and resources, keeps infrastructure centralized while letting teams work independently. Security is built in. Entra ID for identity, Azure role-based access controls for access, managed networks for compliance. Isolation works at project level. Each project can have its own compute data and configuration while inheriting hub-level policies. CI/CD is native. The API and SDK make Foundry fit seamlessly into enterprise DevOps workflows. Compliance is a feature, not an afterthought. Managed networking, audit logging, and encryption come out of the box. I hope you like this video. Thanks for watching. See you in the next one.